In this video I have a lot more words up on the screen than I like to have, but I'll try to pick through it, especially since I know some of you may be looking at lower resolution. If you can, and if you can spare the bandwidth, I do recommend for this one, jump up the resolution by clicking on the settings button in the viewer, and maybe even go full screen so you can really see all the details. Now, what we're talking about here are pH probes. You knew that from the title. But let's take a look at what's really involved in a pH probe to see what sort of a measurement we're usually doing. Here I'm going to work backwards from how I usually explain it. Usually I talk about a phenomenon and I talk about how we could use it. Here I'm going to talk about something that we do and go into the phenomenon that allows it. So notice that what we've got here is just the standard silver chloride electrode. Of course, we have to make sure that we have the appropriate amount of Cl- in our solution, but other than that, we've got ourselves a standard electrode. Now on the other side, notice that we've got basically the same thing. We've got our Cl-, our silver chloride, and our silver. In other words, we've got a reference electrode out here. We have another reference electrode that we're building on the inside. Now if we just set up two reference electrodes, we expect there to be zero difference between them. And we don't usually care about what the counter ion for our ion is. Notice that over here we certainly didn't specify it. But here's a neat little thing that we can do. Suppose that we have this nice fine glass membrane. And what we do is we have a different concentration of hydrogen ion on the inside and outside. Well, that's going to end up creating a junction potential because we have a different amount of H plus on one side or on the other side. The other way you could think of that is just if I've got a layer here, we know that our glass is going to have lots of positive and negative ions making it up. This should be randomly sparse. I said up, but I didn't want to have to erase, so you'll see why I did this in a second. Suppose that I've got more concentration of H plus on this side. Well, they're going to draw the negative ions more to this side. If I only have a smaller amount of plus ion on the other side, they're going to be kind of stuck over here. They may not be loving it, but they're stuck. That's the sort of thing that's going to happen here at the surface. And notice, this is a junction potential. When you get your positive charges biased in one direction and your negative ions biased in another. So let's actually look inside of the pH meter a little bit more, talk through what's in there, and also kind of talk about this caption. I just retyped the caption that was on the figure that we had in our textbook because it wouldn't have fit on this page. So this is a diagram of a glass combination electrode. That's the type of pH meter probe that we're talking about, with a silver chloride reference electrode. Sure enough, that's in there. The glass electrode's immersed in a solution of unknown pH, my analyte solution. So the porous plug on the lower right is below the surface of the liquid. So you'll notice that there's a little porous plug right there that's allowing the contact. The two silver chloride electrodes are going to measure the voltage across the glass membrane. So it's exactly the setup that we saw up here. The glass membrane is going to selectively start binding H plus on one side. That's going to create a bias to bring the negative charge over to one side or another. And then we're going to have that junction potential form right here. We're going to have our known concentration of HCl on the inside. Our unknown is obviously going to be on the outside because that's what we're trying to measure. We have to have a porous plug here to make it in electrical contact. And you can see that the inside is 1/2 cell. The outer half of this probe is the other half cell. The inside part is going to be, let's see, well, depends on how you want to look at it over here, I guess. It's saying outside on this side because it's outer versus the bulb. So I'll just draw an arrow over here and say that this stuff is from this side. What's happening down in the bulb is going to be everything from this side. Here we are. Or we're going to have our known concentration on the inside, our unknown concentration on the outside, and then the rest of our silver chloride setup. So we should have the same potential on the inside and outside if all we were considering was inner reference electrode and outer. That means the only potential that's going to form is going to be between these two. The bias that we're going to have from having a different concentration on each side of that glass, like we saw sketched here. And that's going to allow us to determine a potential between the two sides, which we can then convert into pH. Now, when we look at this, I want to highlight a couple of things. We've got to have the air inlet open because there's a porous plug down here, and we have to have some electrolyte draining out to make the salt bridge and electrical contact. If we leave the plug in up here, we're going to have a slight vacuum form, and it's going to keep any of our solution from draining. You'll have our slow migration that happens through random walking. So there'll be an electrical contact, but it's not going to be fast enough and efficient enough to get a proper reading, and your values are going to be weird and all over the place. So we always have to make sure we open this air inlet, and we also have to treat our electrode very kindly to make sure that we have this plug allowing that solution to flow out, and also to keep this glass membrane clear and clean. We'll talk more about that when we talk about care and maintenance of pH probes. Now, I also want to point out that we usually have a little casing extending down around here. That's why this thing may not look all that familiar at the moment. We're used to seeing that little round thing with these plastic barriers on either side. That's just to make sure that we don't shatter this fairly thin glass membrane, because it'll break very easily, and then we need to go purchase a new pH probe.